Good afternoon, everyone. I am Patrice Lallam with the Great Plains Institute, and I have the privilege of moderating our next session this afternoon. I have roots in both energy and agriculture as a North Dakota farm girl, so it gives me great pleasure to be able to be here today and do this. So the topic we're going to be covering this afternoon is carbon, agriculture, and bioenergy, fostering soil carbon management, and the capture, use, and removal of carbon in the production of bioenergy and bioproducts. And so today I am honored to introduce Roger Johnson, who is the president of National Farmers Union. And he's here today to share his vision for how agriculture and rural communities and economies can contribute to and benefit from the whole chain of carbon management, focusing on ways that we can transform carbon from a pollutant into an economic resource. Roger has a very unique perspective on carbon capture and carbon management, both as the president of the National Farm Organization, and he also served as North Dakota's Agriculture Commissioner from 1996 until 2009. And in that role, he was a member of North Dakota's Industrial Commission, which regulates the state's oil and gas industry. He was also my boss for, for his whole tenure in office. So I'm especially pleased to be able to welcome Roger Johnson.
Thank you, Patrice. It really is a pleasure to be here. I was wondering sort of why I'm here, and I think it probably goes back to years and years and years ago when Brad talked me into going on these different trips around the world to learn about this kind of stuff, back when I was Ag Commissioner. And it was, in North Dakota, the political apparatus works a little differently than it does in a lot of the other states, in that the Agriculture Commissioner, the Attorney General, and the Governor are the Industrial Commission, and that's the entity that regulates oil and gas, does a lot of the coal development policy and those sorts of things. So when Heidi was AG, I was Ag Commissioner, and so I've known her for a long time and known Brad for a long time. And so in some ways, we share really similar outlooks on what ought to happen. But I really want to talk a little more about agriculture, particularly a little bit about ethanol, and then a little bit about soil carbon. And then we're going to just sort of throw this open to Q&A. And my clock hasn't even started, in case anyone is going to start that clock. So I got like 2 minutes free. Jeez. Okay, so I'd really be remiss if I didn't talk just for a minute about the agricultural economy. National Farmers Union represents about 200,000 family farmers and ranchers around the country. We're a general farm organization. We have all kinds of farmers and ranchers who are members: organic, conventional, row crop, small grains, you name it, organics. Well, the challenge between organic and conventional in the ag space is a significant issue that we deal with internally, just like the rest of the industry deals with it on a broader scale. And I'll be happy to talk more about that later. In some ways, there are parallels between what we're here to talk about and what's going on in the ag industry. The ag industry is in tough shape right now. And that's what this chart shows: net farm income, which, think of that as sort of being equivalent to a salary for someone who's working, half of what it was 6 years ago. So that's the chart on the left. On the right, it gives you a broader perspective, a longer time frame, about 20 years there. And in this context, we're always looking for new opportunities to add value to what we're doing in agriculture. And in my judgment, this space, this issue of carbon, is not only a huge problem that the world is confronting, but it can be a huge opportunity for the agricultural industry if we get the policies right, and that's a really, really big if. Now, and I'll talk more about that in a bit, but I want to mention ethanol because as an organization, we've supported renewable energies for a long, long time as a part of the effort to sort of add value to what we're already producing, to sort of decommoditize some of what we're doing, so that farmers can get a larger share of that value for a bushel of corn in the case of ethanol or what have you. In this chart, really, I'm not going to talk long about it because Geoff will talk more about this issue, but the efficiency and the relative intensity of ethanol in its contributions to greenhouse gas emissions has shown marked improvement in just a very short span of time. That's because the industry is really quite new. I mean, most of this industry has been stood up in the last 20 years at most, 15 years, the bulk of it. And so you got new technology and rapid advancements in technology. Okay, the next slide is really an opportunity slide. And I put this in here to sort of compare the ethanol industry to the rest of what's in the room here. And on the left, what this shows is that the stream of CO2 coming off of ethanol plants is virtually pure. You don't have to clean it up. So in a lot of ways, the economies associated with collecting that CO2 that's being emitted in most cases into the atmosphere ought to be pretty simple compared to the other industries. And then the graph on the right just shows you the volume. So while it's easy, it's not a big piece of the picture, but it's certainly some of the low-hanging fruit is the point I would make with this slide. And then the last slide is a part of the graph that's in the other information, or the map that's in the other information you all have seen, but it's just with less information on it. So the yellow dots are all the ethanol plants scattered around the country, and the CO2 pipelines are the black lines, and it kind of shows the mismatch and the enormous opportunity. So if the economics work, you got a whole bunch of clustered plants up there. You ought to be able to tie a lot of these plants together, build those pipelines, and move them to where the market is. So that's all I'm going to do in terms of slides. But I do want to make some comments about, if you've read the reports, and you all have probably read a whole lot of the IPCC reports and the other reports on this issue than I have, but one thing that comes through pretty clearly in those reports, as others have said, is everyone needs to participate in this. Another thing that comes through pretty clearly is agriculture is a contributor to greenhouse gases. I think Rebecca or somebody had an earlier slide up today. If she didn't point it out on the slide, but it showed the percentage of land, which is probably a pretty close approximation to the agricultural space. Agriculture contributes about 9% of the greenhouse gas emissions in this country, and yet it is about 3% of the GDP. So it's a larger than proportionate contributor, but it's also a significantly larger opportunity. Lots of studies have demonstrated that agriculture can actually be a net sink for carbon. And the challenge you have in the ag industry is there are about 2 million farmers around the country. Now, not all of them are of the same size, obviously, but a number of you have talked earlier in the conference about one of the benefits you have is you've got relatively few companies in a space, and so the ability to make a decision can be implemented pretty rapidly. Well, with farmers scattered all over the country, you don't have that same ability. So you really need to get the public policy kinds of pieces right. Back in 2006 to 2010, North Dakota Farmers Union, and then later with National Farmers Union involvement as well, we stood up a carbon aggregation project for farmers. And there are there's just lots of robust scientific information that says if you follow certain practices, you use precision farming techniques, you do certain no-till practices or minimum till practices, certain managed grazing practices, certain wetland restoration practices, all these kinds of things, if farmers do them, they in fact will sequester CO2. And there's all debates about whether it's permanent and all that kind of stuff. And so around that are the public policy questions. We stood this project up, and we had millions of acres signed up, farmers voluntarily signing up in 30 states around the country, and many millions of dollars of payments had gone out because this project was a part of what was then the CCX, okay, the Chicago Climate Exchange. And that was sort of all built on the presumption that we remember in the 2008 election, well, some of us remember it was Obama versus McCain. They both supported cap and trade. There was a presumption in this country that we're going to have cap and trade as a national policy. Well, when that flamed out, the CCX virtually vanished overnight. It took about a year. It wasn't even a year after actually the decision was made that it wasn't going to happen. And that vanished. And so that project has since ceased. But I mention it because if you get the economic incentives right with public policy, there's significant demand out there from a lot of big industry players in the food and agricultural space that want to make sustainability claims, carbon claims that they can only make legitimately if there is a system that's put in place all the way from the final food product back to the production level that demonstrates that the claims that are being made on that food product, in fact, are adhered to through that system. There is a growing interest in the agriculture space by a lot of different players to line up all these different players, from the Walmarts and the General Mills and literally hundreds of companies like that, all the way through the intermediate suppliers, down to the farmers. Field to Market's a good example of that. The Noble Institute in Oklahoma, a lot of you probably know that because that's old oil money that was used to set up that institute. That was put in place. And they have, as a major project right now, the ecosystems services, I forget, ESRs, I think what the acronym is. But anyway, it is a credit, basically, that they expect to be able to use to induce or to incent farmers and ranchers to follow these kind of climate-friendly practices. And if they do that, then they'll get paid by those markets that I talked about. So my point is, there's a lot that's happening in this space. If we had the right public policy, I think this could scale up pretty rapidly. And I'm done.
Thank you, Roger. And now I'd like to introduce Geoff Cooper, who is a Wyoming native, I learned in reading his bio today, and also is the current president and CEO of the Renewable Fuels Association. And that association collectively represents the majority of ethanol industry leaders and supporters across the country. Their mission is to increase the production of and use of renewable fuels and to create a dynamic, robust ethanol industry. Prior to his role as president and CEO, Geoff was the RFA executive vice president, overseeing market and policy research and providing regulatory support and strategic planning for the association and its members. So Geoff is with us today to talk about pathways for transforming the biofuels industry through a carbon lens, and to also talk about RFA's engagement on policy issues at the federal, regional, and state levels. So with that, welcome, Geoff.
Great, thanks so much. And I'm going to speak from the podium so Roger doesn't have to look at my back the whole time. But I really do appreciate the invitation to be here. Thanks, Brad and Doug, for having me. And the first thing I want to do is cast my vote to return to this facility as often as possible. As it was mentioned, I grew up about 100 miles east of here. I spent a lot of time in these mountains as a kid. And unfortunately, today I spend a lot more time in the swamp than I do in the mountains. But I did want to share just a few thoughts about how the ethanol industry is thinking about carbon capture and sequestration, and really kind of our current thoughts on our industry's role in further decarbonizing liquid transportation fuels. I usually like to start with this slide when I'm giving this sort of presentation. several years ago, and I don't know how easy that is to see, several years ago the National Academy of Sciences published a study by a group of researchers at NASA that really was pretty groundbreaking. They used a new satellite sensing technology to measure photosynthetic activity all around the world using a new technique that they called chlorophyll fluorescence. And essentially they came up with all these very vibrant iridescent maps, and the brighter the colors, the more photosynthetic activity was happening. And it's really a pretty interesting study to look at. But what they found in that study is that during the growing season, the Midwest region of the United States boasts more photosynthetic activity than any other spot on Earth. And specifically, they noted that corn plants are very productive in terms of assimilating carbon dioxide from the atmosphere. So I like to start with this because I think it's hard to overstate the resource we have in our ag sector in the Midwest part of this country. We have 400 million acres, give or take, of productive cropland that's acting as a solar panel of sorts, soaking in that energy from the sun, and at the same time vacuuming huge amounts of CO2 out of the atmosphere. So what happens to that CO2 that is being assimilated by these crops? And I want to dwell on this for a little while because I think there continues to be some misunderstanding about the life cycle of crop-based biofuels, where that carbon goes when it's sucked out of the atmosphere and sequestered in a plant. So in the case of corn, some of that carbon gets locked up in the kernel, in the grain. Some of it is stored in the stalks and the leaves and the husks that support the grain, and then some of it is sequestered in the root system in the soil. And if you're producing corn in a no-till system, like Roger mentioned, that carbon stays there, right, unless there's some activity to dredge it up. About 40% of our corn grown today is in a no-till system, and so our farmers are accumulating a tremendous amount of carbon in the soil and really building that soil organic carbon over time. So once that grain is harvested, once that corn is taken from the field and goes to the ethanol plant, it goes into fermentation. And in the fermentation process, some of that carbon is released into the atmosphere. As Roger said, it's a very pure, probably the cleanest source of industrial carbon available, carbon dioxide available at scale today. We do have roughly 25% of our ethanol plants are today capturing some or all of the CO2 from fermentation. A lot of it is going today into things like dry ice manufacturing and flash freezing and carbonation. There is a little bit going into EOR, and I'm going to talk some more about that. And then, obviously the remainder of that carbon that was originally in that corn kernel ends up in the ethanol. And that ethanol is burned in your vehicle, comes out the tailpipe as biogenic CO2, and this whole cycle starts over again. And so we're really talking about, with biofuels, a cycle where we're recycling atmospheric carbon. Some of it's getting stored in the soil, yes, but today, most of it is being vented from fermentation or returning to the atmosphere when that fuel is combusted in the vehicle. But of course, we do, you could look at that process and say that ethanol and other biofuels are carbon neutral, but there's no free lunch, right? It takes energy to make this whole process work, both at the farm level and in the ethanol plant. And that's where life cycle analysis comes into play, where we're measuring the amount of energy invested in this production process and the emissions associated with that process as well. And so what this chart is showing is the carbon intensity, which is basically the sum of all those emissions through that kind of cradle-to-grave life cycle of ethanol that is used in the California market under the low-carbon fuel standard. And then the little orange line toward the bottom is the data we have on the Oregon Clean Fuel Program, the ethanol used under that program. And so what you see by looking at this, the lines at the top, the red line and yellow line, are gasoline. That's the carbon intensity of gasoline in those two states. And you can see it somewhere around 100 grams per megajoule. But what you see with ethanol is over time, the carbon intensity of corn ethanol used in California has fallen dramatically. The last quarter that we have data for, which would be Q4 of 2018, the average gallon of ethanol was reducing greenhouse gas emissions by 34% relative to California gasoline. In Oregon, that reduction was more, it's about 40%. The difference there is just in how they predict land use emissions, and that's not something I'm going to get too much into today. Again, I kind of want to point out the declining trend that we've seen since 2011. I think there's really two primary reasons that explain that. Number one is the California Air Resources Board is using far better data and modeling tools than were available when they started this program back in 2010, 2011. But the second and probably more important driver is that our industry has responded to the signal that was sent when CARB adopted this program, put a value on carbon, and provided an incentive to our industry to get better. And that is in fact how they have responded. We've seen tremendous investments made specifically so our facilities can participate in this program and have a fuel that they can sell into that market that has an attractive carbon intensity score. And that 34% reduction, again, kind of the average ethanol pathway in California today, if you're taking that ethanol and making E85 and 85% ethanol blend with it and putting it in a flex fuel vehicle, you're already meeting the California 2030 standards. In fact, you're far surpassing those standards. We have seen tremendous progress in our industry in response to the program in both California and more recently in Oregon. Ethanol is responsible today for about 40% of the total greenhouse gas emission reductions that have occurred under the low carbon fuel standard, which is quite significant. So I started out talking about how biofuels like ethanol recycle atmospheric carbon, but what if we could do better than that? I mean, what if we could not only recycle the CO2 that we're sucking out of the atmosphere, but store more of it underground via the sorts of agricultural practices that Roger was talking about, and through CCS. And the short answer is we can do those things, and in fact it is happening today on a somewhat isolated scale, but it is happening and I think really shows the potential for the future. Roger had a chart kind of like this. This is showing the results of some modeling that RFA has done using the Department of Energy's GREET model. And the bar that is furthest on your left shows kind of the current average dry mill corn ethanol plant today. When you look at all the phases of the life cycle, and again, you take into account the co-product credit because some of the grain we're processing ends up as animal feed, you end up with net emissions in that process of about 57 grams per megajoule. Again, gasoline's around 100, so we're at about a 40% reduction on average today. That's kind of the average across the industry. The bar in the middle is showing where we know we're headed just within the next 3 to 5 years based on emerging technologies and new technologies that are already being adopted, efficiencies both at the ethanol plant and also on the farm. We know crop yields are going to continue to increase. We know the amount of natural gas that our ethanol plants are using to generate steam continues to come down. So as we've done some kind of techno-economic modeling, we think by 2021, 22, that middle bar is going to kind of be the average for corn ethanol, about a 44.5 gram per megajoule average, and that would be a well over 50% reduction versus gasoline. But the one that's really exciting, I think, especially for this audience, is the bar that's on the furthest to the right, which is maybe a little further out, but again, there are some facilities, some companies that are doing these things or actively looking into doing these things today. And what it shows is, again, if you could continue to see continuous improvement at the farm scale with agriculture practices, continuous improvement at the ethanol biorefinery, and then you tag on carbon capture and sequestration, and you put all that CO2 that's coming out of fermentation and send it to EOR or saline injection or what have you, it ends up being a fairly significant credit to the corn ethanol life cycle. And then if we have a mechanism, as Roger said, to measure and verify and validate soil carbon sequestration that's happening in no-till systems and other efficient agricultural practices, you know, a lot of that's happening today, and we're not receiving any credit for it because there's no mechanism, no metrics, no modeling to really account for that today. If we figure that out, that's another fairly significant, you know, carbon sequestration credit that would accrue to the corn ethanol life cycle. And so now all of a sudden you're under 10 grams per megajoule, somewhere in that 6 to 10 gram range, for, you know, technologies that are emerging today and are being applied today. And if we see those used more broadly across the industry, you know, we could have, you know, typical grain ethanol reducing GHG emissions by 90% or more relative to gasoline. This is coming. I truly believe that we're going to see these sorts of technologies and pathways in the next 5 to 7 years, if not sooner, in our industry. You know, of course, it's going to take some things to get us there, and I'll kind of finish up with that. You know, getting to a place where that pathway on the furthest right is the norm is going to take some things, right? I mean, we're going to need a value on carbon in every market, and there's various ways to do that. Of course, we've done a lot of talking about 45Q. My organization strongly supported the 45Q reforms. We were a very proud and active participant in the coalition that helped get that across the goal line. The state low carbon fuel standards are another way. When you hang a value on carbon, our industry responds to that. And that's why we're part of an active discussion that is now happening in the Midwest about the potential for a low carbon fuel program in the Midwest states, or, you know, a single state or group of states in the Midwest, which 10 or 15 years ago, had you suggested that, I would have been chased out of the room in any gathering of farmers and ag constituents. Today, it's a much different story because they've seen the value and the reward associated with these sorts of pathways. So, you know, we've talked about stability and certainty. I'm not going to dwell on that. I think we all understand the importance of having that with our policies. You know, we're going to need focused investment in CO2 collection infrastructure. You know, again, I think the book that was released today at noon has a really nice description of the Use It Act in there. We're strongly supporting that proposal because it would, I think, really jumpstart the second phase of getting the infrastructure in place to connect the dots that Roger showed on his map, where we've got a huge CO2 resource and just really no way to get it to where the markets are today. You know, when we talk about EOR, I think we need reasonable verification and validation and monitoring protocols. We're seeing some steps in the right direction there. We need policies that encourage and reward and give credit for soil carbon sequestration at the farm level. And we need to continue improving our modeling and tools for assessment and measurement of what's happening both at the field scale and at the ethanol plant. So that's you know, that's a lot of things on the to-do list, and some of those are fairly heavy lifts, but I know that working with many of you, we can certainly accomplish those goals and keep moving the industry forward. So thanks very much for that, and look forward to your questions.